Welcome back, everybody. Here is a new topic, new question. This we're going to deal with calculus today. We want to find the equation of the tangent to a curve, and we have to use one or two or three derivative rules for this one. And here is the question. So we have this function, a curve, y equal to 2 over 1 plus root x. We want to know the equation of the tangent line to the curve, and we want to know that equation at the point of tangency 1, 1. Okay, so that's what we need to do, and let's go ahead and do that. So first thing first, we're going to simplify this equation so that it is easier to deal with. So to do this, to simplify, first let me do a review quickly. We want to use this derivative rule, and that's a reciprocal rule for derivative. So d dx of 1 over f of x, so that means the derivative of a reciprocal function is given by negative f prime of x divided by f of x all squared. All right, so to do this, we're gonna make this equation, the function, looks like a reciprocal, even though there's a 2 up there. We're going to make it 1. So we're going to divide everything by 2. So that means basically dividing the top by 2 and each of the terms in the denominator by 2. And what you will get y equals 1 over 2 plus square root of x over 2. So in this context, our f of x is the denominator, 1/2 plus square root x over 2. Okay? And then what is f prime of x? We have to do the derivative of that. And remember, the derivative of the constant is 0. And then the derivative of that, so let me rewrite that as this is 1/2 the square root of x. Okay, that's what that is. So in this case, what we will have, it will be, we're going to change the 1/2. Sorry, we're going to change the x, the square root of x, to the exponent. That would be x to the 1/2. F prime of x is equal to, so we're going to go through and take the derivative of that. So 1/2 stays on its own. We're going to bring the 1/2 exponent to the front according to the rules of derivative. That's 1/2 and x, and then 1/2 and then subtract 1. That's the rules of the derivative. Okay, so here it is, and then we when simplify that, that becomes a quarter, and then this times 1 over the square root of x, because 1/2 minus of 1, that is negative 1/2, and x to the negative 1/2 is 1 over square root of x. So simplify more, 1 over 4 root x, that is the f prime of x. Okay, so let's rewrite that. So f prime of x now is 1 over 4 root x. Great. Now we're going to go and we're going to use the reciprocal rule, which is right up here. We're going to plug numbers in. We're going to plug in f prime of x and then f of x squared, and then we're going to go and simplify. All right, let's do that. Once you have substituted the values of f prime of x, which is up here, and we found it here, okay, once you have this right there, plugged back into the reciprocal rule, and then the denominator is f of x squared, and then there's a negative in front. We're going to plug numbers in. Here we go, the actual values, expressions, and a square, and then we're going to simplify that. And it's when you simplify the denominator, you get 1 plus root x over 2 all squared, and then you can further simplify this, and this basically becomes negative 1 over root x over 1 plus root x all squared. All right, and that's because of this denominator down here, 2 squared, that's 4. So 4 divided by 4, that's 1. So just what is left in the denominator here would be 1 plus root x squared, and the top would be negative 1 over root x. Okay, Now that we have this, we don't have to do anything else with this. We just have to now plug in the slope value that we want, because the question says find the equation. And to find the equation of the line, we need to find basically two ways to do this. You need the slope, okay? And because of we know we have a 0.11, and this, what we found is the slope of a tangent line, and in terms of the value of x, this actually represents the slope of a tangent line, right? So what this is m. Now we just have to now choose the point 1 for x as in the coordinate, plug it in there and find out what that is. So what we have will be negative 1 over 1 plus 1 squared. And then what you will get is negative 1/4. So that's equal to your slope. Here it is. We got the slope. Great. Now that we got the slope, we're going to go back and we're going to now write the equation of tangent line. Now, for the simplicity's sake, we're going to use this general form. Okay, so here we're going to plug numbers in. Y minus 1 is equal to negative 1/4 x minus 1. And then if you really want to put it in a general form or slope-intercept form, the last step will be y is equal to, actually, let me write the general form first. The general form will end up being 4y plus x is equal to 5. And then from this point on, you can actually change that to the slope-intercept form if you want. But these two, this one and this one, they're both the same. They represent the equation of the tangent line to the curve that is given by this function originally. We have there, that's the equation of the curve that we have, the function. So here it is. And that is the final answer. All right, I hope you found this useful. Come back again for more practice in math and calculus. Be well.